Hello everybody, this is Dr. Vishal Trivedi from Department of Biosciences and Bioengineering, IIT Guwahati. And within the electrophoresis, we were discussing about the basic principle of electrophoresis, followed by we have also discussed about the vertical gel electrophoresis and how to perform the vertical gel electrophoresis. So, in today's lecture, we are going to start discussing about the horizontal gel electrophoresis. So, in the horizontal gel electrophoresis, the electrophoresis in this gel system is performed in a continuous fashion with the both electrodes and the gel cassettes are submerged within the buffer. What is mean by the continuous electrophoresis is that the current is not flowing through the gel, which means it is actually continuous. For example, when you are running the vertical gel electrophoresis, or if you recall, you have the two chambers. One is the top chamber where you are keeping the buffer, okay, and which is the negative electrode, and then you have the lower chamber where you have the again the buffers, okay, and then you have the positively charged electrodes, okay, and in between these two chambers you have the gel actually which is been sandwiched within the glass plates. So, here you have the polyacrylamide gel, and because and so the current cannot directly go from the negative to positive electrode, whereas current has to go through with this gel, and then the gel is actually connecting the two electrode chambers. Compared to that, in the horizontal gel, you have a chamber where you have the negative electrodes and then you have the positive electrode, and then a gel slab is being submerged within the buffer. So, the buffer is on the top of the gel, buffer is on the bottom of the gel, and that is why the current can freely move throughout this system. So, the current can flow throughout these buffer solutions, and this buffer solution is also continuous, whereas in this case the two buffer chambers are connected through the gel. So, the electrophoresis chamber has two platinum electrodes placed on both the ends and are connected to the external power supply from a power pack, which supplies a direct current or the DC voltage. So, you have a electrophoresis chamber where you have a negative electrode and the positive electrode on both the side, and then these electrodes are connected through the power cord to the power pack, and this power pack can supply the DC voltage of the any amount. The tank is filled with the running buffer and the gel cassette is submerged inside the buffer. There are additional accessories needed for casting the agarose gel, such as the comb. Comb is required to prepare the different wells, then you require the spacer, then you require the gel caster. So, how to run the agarose gel electrophoresis? So, before discussing about how to run the agarose gel electrophoresis, let us understand the reagent as well as the instruments what you are required. So, for the buffer, the purpose of each reagent used in the horizontal gel electrophoresis is are as follows. So, you require agarose. So, agarose is a polymeric sugar which is used to prepare the horizontal gel for the DNA analysis. Then you require the ethidium bromide. So, ethidium bromide is a dye, it is actually going to use to stain the DNA. So, ethidium bromide is required for the staining of the agarose gel to visualize the DNA. Then you require the sucrose. Sucrose is required for the preparation of loading dye for the horizontal gel. If you remember, we were using the glycerol in the case of the SDS page. So, you have a choice, either you use the glycerol or to the sucrose. The purpose is that you want to provide a high density solution, so that whatever you load into the gel will remain within the gel. And then you require the tris HCl. The tris HCl is a component of the running buffer, and then you require the bromophenol blue. Bromophenol blue is a tracking dye to monitor the progress of the electrophoresis. Now, once you prepare the buffer and the reagents, then you can actually perform the horizontal gel agarose electrophoresis. To performing the agarose gel electrophoresis, the first you have to cast the gels compared to the acrylamide gel, where you are actually going to add the cross linkers, and then you are going to add the timid and APS to induce the polymerization reactions. Here you are actually not going to do that. For casting of the gel, what you are going to do is you are just going to take the agarose. So, agarose is a sugar. So, when you boil this and is a polymer actually. So, when you boil this sugar, it actually going to form a jelly like solutions, just like as you might have seen when you cook the rice in your home, and if you boil the rice, it actually gives some amount of starch. So, it is agarose is also a similar kind of carbohydrate. So, where you if you boil the gel, it actually forms a jelly like solutions, and then if you pour that jelly like solution into a tray which actually contains the comb, once the jelly like solution get cooled down, then you are going to have a gel slab. So, for the casting of the gel, different steps to cast the agarose gel for horizontal gel electrophoresis are given in the figure. The agarose powder is dissolved in a buffer, either the tris EDTA buffer or TB buffer, and then you heat it to melt the agarose. Hot agarose is poured into the gel cassettes and allowed it to set. A comb can be inserted into the hot agarose to cast the gel well for loading the samples. In few cases, we can add the ethidium bromide within the gel so that it stains the DNA while the electrophoresis is going on. So, what you are going to do is you are going to take the required amount of the agarose into a beaker, and then you boil this. You can use the burner or you can use the microwave, and then once it get dissolved, then at this step itself you can actually have a flexibility of adding the ETBR, and then you pour it into the gel cassette, and before it gets solidified, you can also put the comb so that it is actually going to give you the wells. And once the wells are prepared, then you can load the samples onto that particular wells, and you can be able to dissolve the gel DNA to visualize. Now, the gel cassette is placed in the electrophoresis tank, submerged completely, and the DNA are loaded into the well with the help of a pipette man and run with a constant voltage. So, once the gel is prepared, then you can just take out the gel from the gel cassette, put it into your running buffer, putting it into the electrophoresis chamber, and then you connect, then you load your DNA, and then you connect it to the DC power. With the help of the power bank, you can supply the constant voltage, and then you can resolve the DNA into the agarose, and the DNA runs from the negative to the positive end, and the ethidium bromide actually runs present in the gel stain the DNA. Observing the agarose gel in the UV chamber shows that the DNA stained with the ETBR as the orange colored fluorescence. So, what happened in this case is that when you have a negatively charged electrodes, and then you have a positively charged electrodes, and then you have a place where you can actually load the DNA. So, what will happen is the DNA, because DNA is negatively charged, it actually runs in this direction because it runs towards the positively sides, whereas the ETBR is a positively charged dye. So, ETBR is actually runs in this direction. So, while they are running in the opposite directions, the ETBR stains the DNA, and ETBR stains the DNA within the major and minor group, which means the ETBR actually intercalate within the DNA. So, you know that the DNA has two strands, and if these two strands are actually having the bases on the side. So, within the bases the ETBR is getting intercalated, and as a result it actually gives the orange fluorescence when you visualize them under the UV. And what you see is when you keep the DNA, when you keep the agarose gel into the UV chamber, that you are going to see the orange color bright DNA glowing within the agarose. There is no destaining step required, because the ETBR only gives the fluorescence when it interacts with the DNA and intercalate within the bases. That is why there is no destaining step is required, because the ETBR which is not interacting with the DNA does not give the orange fluorescence. And what you can see is, for example, in this particular representative image, what we are showing is that these are the plasmid DNA which has been resolved onto the agarose gel, and they are showing you the intense stain, and what you see is this blurry signal from the gel is actually the RNA. So, RNA is never been get resolved and never give you the compact band. Because of that, the RNA is going to give you the hazy appearances. So, with this we have given you the complete theoretical information how to perform the agarose gel electrophoresis and how to run the gel electrophoresis. But the theoretical information is not enough. That is why I would like to take you to my laboratory, where we have prepared a small demo clips, where we have shown how to boil the samples, what are the precautions you should take when you are boiling the agarose solutions, and then how to pour it and how to prepare the gel, how to prepare the wells, how to load the DNA, what are the precautions you should take while you are loading the DNA into the chamber, into the wells, and ultimately how to visualize these gel into the UV chambers, what are the precautions you should take when you visualize the DNA into the UV chambers, because as you know that the ETBR, UV and all these are dangerous for it's dangerous for the human being. ETBR is a carcinogenic molecule, so it actually causes the cancer. So, that is why you have to always wear the gloves when you are performing the agarose gel electrophoresis. So, in this demo the students have shown you the how to perform the horizontal gel electrophoresis, the agarose gel electrophoresis. Today we are going to give you the demo of the agarose gel electrophoresis, which is being used to resolve the DNA. So, in a typical agarose gel electrophoresis apparatus, what you need is you have a horizontal, you have the buffer chamber where you can have the two electrodes, you can have the cathode, you can have the anode, which is the black color electrode, and then you can have the cathode. So, this cathode and anode will go and house into the buffer chamber. Connecting these cords to the power cord, you have the two different cords, one is red cord and the black cord. And apart from this, you also need a gel caster where you can be able to cast the gels. So, this is the small gel tray which you can use to cast the agarose gels. And apart from that, you also have the comb which actually can be used to prepare the well. And besides this, the reagent what you need to perform the agarose electrophoresis, you need the agarose powder, which you can buy from the Sigma or any other company of a very high quality. Then you require the ETBR, which is a staining dye, and as you can see that the ETBR is being kept in a vial which is covered with the foil, because the ETBR is light sensitive and so it should be protected from the light. And apart from that, you also require the running buffer, which is the 50x TAE. And so let's start the casting of the agarose gel and performing the gel electrophoresis. Before you start the preparation of the agarose gel, what you have to do is you have to set the tray so that you can be able to pour the agarose into that particular gel, particular tray, and then you will be able to cast. So what you have to do is you have to take this tray, you have to very carefully clean the tray and with the water as well as so that it will be free of any kind of contaminations and any kind of, because you know that the DNA is very sensitive for the DNase and the other kind of enzymes. Then what you have to do is you have to keep this tray in this way into this gel caster, and then with the help of these screws you have to screw the gel tray, and you have to tight it. And as you can see that I am tightening it both the screws simultaneously, so that it will be got completely sealed. And then now once this tray got sealed and you are ready to pour the agarose, what you have to do is you have to first put the comb, and when you put the comb, what you have to do is you have to ensure that there is enough gap between the comb as well as the lower end of the comb as well as the tray, so that that space the agarose is going to fill, and that's how it is actually going to help you to prepare the well. So for a typical agarose gel electrophoresis, what you have to do is you have to first prepare the 1x TA buffer, and for a typical this kind of small chamber, you require somewhere around 300 to 400 ml buffer, and for the gel also you require at least 30 to 40 ml. So so for a safer side, what we can do is we can just prepare the 50 ml agarose gel, and for a DNA of around 1 kb to around 1 kb, you can actually run a gel of 0.8%. Because as the DNA size will lower down, you have to keep increasing the size of the agarose percentage. So for example, if you are interested to explore the apoptosis or DNA segmentations, in those cases the gel band or the DNA band what you are expecting is from 200 base pair to higher molecular weight. So in those cases we normally run the agarose of 2%, but in most of the cases what we do is we run around 0.8% agarose gel, and that is good enough to resolve most of the DNA sizes. So for preparing a 50 ml 0.8% agarose, what you need is you have to just weigh the 0.4 grams of agarose, and then you have to boil it into the microwave, and then you can prepare. So let's understand how to do that. Now what we have done, we have weighed the required amount of agarose, and then we have prepared the 1x TA buffer, and some of the buffer we have poured into the chamber itself. And for preparing the agarose gel, what we have done is we have taken up almost 70 ml of the buffer, because when you boil there will be always a loss of some buffer. So what we have calculated for the 50 ml, and now we are keeping 10 to 15 ml of more water, because when you boil this you are going to evaporate, the water is going to evaporate, and that's how you are going to lose some water. So once you're going to pour the agarose into the buffer, and then you are going to do the boiling. So what you can do is you can use a microwave, and you just turn on the microwave, and what you have to ensure that the microwave is actually boiling the agarose and melting it. So in this process what will happen is that the water will going to warm up, and the agarose is going to melt, and once the agarose is going to melt, it is actually going to swell, and it is going to take up the water, and in that process it is actually going to make a viscous material or the viscous jelly like material, and that is what is agarose gel. So but because it is actually going to boil, it is actually can also come out from the beaker. So you have to keep stopping and keep checking that is something what is not happening, and in between you have to always mix, because the agarose is made up of sugar, so it also can get charred if it get localized heating. And once your agarose is going to heat up, then you can be able to use that, and you have to ensure that you boil it very thoroughly, so that all the granules what is present in the the agarose should be get melted. So let's check whether the agarose got melted or not. So for checking, what we do is we have a different kinds of the gloves, which the gloves like we're made up of rubber, and these are the gloves what you can use for touching the hot solutions, because our normal gloves what I am wearing right now is not good enough. So we have to heat up little more, because still I could see some of the agarose granules. Once this step is over, then you have to just take out the agarose. What you see now is the water is boiling right now, okay, and vapors are coming out. So this is actually a rough estimate that you are going to lose somewhere around 10 to 15 ml of water in the process of boiling. Now what you have to do is you have to just let it get cooled for some time, and then you have to add the dye. So in this case we are adding the ETBR. So once it is get cooled down, then you can just add the 3 microliter of ETBR dye. And remember, ETBR is a carcinogenic dye, so you have to be very careful. You always have to wear the gloves, and you have to discard these tips very thoroughly, or very because you don't want to contaminate the environment. So this tip as well as all these buffer has to be discarded in a way so that it should not get out. So you add the ETBR, and then you keep this tip in a secured place so that you will be able to throw this in a trash bag, which is meant for collecting the carcinogenic material. Now your solution is ready, and I can pour this into your tray. So you can just pour this into the tray, and we have to wait for some time so that it should get solidified, and then we can load the DNA and we can run the agarose. Now you can see that the agarose gel is being solidified, and you can see that it is clear, so there is no granules or the granulate or the precipitated material present. And now what we have to do is we have to remove this comb, and we have to keep it into the chamber, and then it is going to be ready to use. So before you do that, you have to add some amount of buffer into this tray. So what you have to do is you have to add some amount of buffer, okay, and then you have to very carefully, without making any movement in the longitudinal direction, you have to vertically uplift the comb into the top chamber like this, okay, and that actually is going to prepare the wells. So what you can see now is the wells in this particular agarose block, okay, and once you are sure that there is no leakage and all these wells are good enough, then what you can do is you can unscrew these tray or the cassette, and we are going to remove the comb. So what we are going to do is we are going to remove this into the chamber, and then we are going to remove the comb. So very carefully you remove the comb, okay, and then you are going to fill the chamber with the buffer. So when you fill it, the whole buffer the gel is going to be submerged, and that's why this particular type of gel electrophoresis is called as the continuous gel electrophoresis. Now what you can see here, that we can see the wells in the gel. So if you see the gel, you can see the well actually, and now we are going to load the sample into those wells, and then we are going to connect the chamber to the electrophoresis power supply, and then it is going to perform the electrophoresis. So to prepare the DNA sample, what we have done is we have actually 10x loading dye. So accordingly you just take the DNA, you add the small amount of TE buffer, and then you add the loading buffer in such a way so that it's going to be 1x, and then you are going to load the sample. So in this case we are loading the 20 microliter of the sample. So you are going to take the sample into the pipette, okay, make sure that there is no air bubble, and then you are going to visualize the gel. And what you can see actually, or sometimes if there is a problem in looking at the wells, or there is a problem of visibility of the wells, because sometimes the lower chamber or the lower background is also going to be transparent. In that case you can just put a black paper at the place where you have the wells, and that actually is going to allow you to see the well properly. So let's see how to load this. So you hold your pipette, okay, and then you bring your tip next to the well, okay, and then you load the sample, and what you will see is that the DNA is getting filled into the well. So now see here how I am loading the sample, okay. So I have taken the 20 microliter, and first I will do is I will take my tip into the well, and then I will load. What you will see is when I am loading, I will very carefully, slowly I am keeping my tip out, okay, so that the whole well is going to fill with the tip. But what you have to remember is that while your tip is inside the well, you should not leave your plunger, so that it should not create any air bubble, because if that happens, the DNA will come out. Okay, so now what we'll do is we'll connect this to the cord. So the black will go with the black, the red will go with the red. So before doing so, we have to put the lid so that there will be no evaporation of the buffer. So you just connect the black to black and red to red. And now we have to turn on the power pack. So in a power pack you have a switch here which actually allows the turning on. Connected the chamber or the electrophoresis chamber with the power supply unit. We have set it at 80 volt and now it is running. And what you will see is once the DNA tracking dye will reach to the end of the gel, then we are actually going to remove the gel from the apparatus. And then since we have already added the ETBR into the gel, the ETBR is going to run from the negative side to positive side, whereas the DNA is going to run from the towards the positive side, because DNA is negatively charged and ETBR is positively charged, so they will run in a opposite direction. So while they are running, the ETBR is going to intercalate within the bases of the DNA, and that's how it is actually going to stay in the gel DNA present in the gel. So then after that, what you have to do is you have to take out this tray and put it into the gel dock machine, and that actually is going to visualize.
Then close the thing. Application: nucleic acids with ethium bromide, exposure, optimal exposure, or we can select manual also. Then we will acquire the images. Now we can find here, this is the DNA ladder, this is the PCR amplified product.
So in the demo, I have explained each and every aspect related to the agarose gel electrophoresis, how to perform the gel electrophoresis, and with this I would like to conclude our lecture here. And in a subsequent lecture, we are also going to discuss different variants of the electrophoresis, gel electrophoresis, and how you can be able to utilize them for exploring the answers or for solving the experimental questions. Thank you.